Both hydraulic systems and the standby hydraulic system have separate control input mechanisms for the rudder PCU. All three of them have individual jam protection mechanisms. When either system A or B is jammed or disconnected, the main rudder PCU detects a pressure imbalance via the Force Flight Monitor, FFM. It's important to understand this because the FFM, after 5 seconds, automatically turns on the standby hydraulic pump, standby rudder shutoff valve, and pressurizes the standby rudder PCU. Lights and annunciators are displayed in the cockpit when this condition occurs. The rudder has a maximum deflection of 29 degrees left and 29 degrees right. The rudder feel and centering unit gives simulated feel to the rudder pedals and centers the rudder and rudder trim inputs in the rudder PCU. When a pilot presses his rudder pedals, a roller is moved and springs are compressed, supplying feel force to the pedals. When the pedals are released, the roller moves to a detent and the system moves to a neutral position. The rudder may also be operated manually through the electric rudder trim control. This changes the rudder neutral position. One of the two rudder trim switches inside the single rudder trim control is connected to the Flight Data Acquisition Unit, FDAU, to record rudder trim position. The rudder trim indicator shows the amount of rudder trim in units. Rudder authority is limited when airspeed is higher than 137 indicated knots, in order to provide protection after takeoff and before landing. Dutch roll is an aircraft movement where the tail moves from side to side when there is input in the ailerons or rudder. In smaller aircraft, this condition is partially dampened. However, in larger aircraft, auxiliary systems like the yaw damper on the 737 NGX are used. This is due to the faster airspeed and higher altitude at which they fly. Yaw damper systems give input to the main and standby rudder PCUs via valves and actuators. The yaw damper actuator input is mechanically added to rudder pedal inputs. Both inputs may move the rudder PCU piston and the rudder. However, rudder input from the yaw damper is not reflected in rudder pedal deflection. The yaw damper system is made up of a main and standby yaw damper. The main yaw damper is powered by the hydraulic system B, and the standby yaw damper is powered by the standby hydraulic system. The yaw damper's system functions are turn coordination, gust lock prevention, and Dutch roll prevention. We've had a look at different flight control surfaces and systems on the 737NG. Now, we're going to discuss two of the three primary main use components, which are flight control cables, flight control panel, and flight control hydraulic modular packages. These won't be discussed in this lesson as they don't directly interface with flight crew or affect the airplane's operation. Flight control cables are used to give mechanical input to each feel and centering unit, then to each power control unit, PCU. The feel and centering units provide artificial feel forces to the controls and pedals, and also sets them to neutral positions. The PCU is responsible for directing hydraulic fluid in order to achieve control surface movement. Both these components were discussed in the respective sections of this lesson. The flight control panel, located in the forward overhead panel, has a series of hydraulic control switches and caution lights for the flight control systems. These are flight control switch, 2 switches, 1 for each hydraulic system, with 3 positions: on, off, standby rudder. The flight control's shutoff valve is powered by a 28-volt DC motor. On position is the normal operating position. Hydraulic system pressure is on to the elevators, elevator feel computer, ailerons, and rudder. Off position. hydraulic system pressure is removed from the elevators, elevator field computer, ailerons, and rudder. Standby rudder position. It has the same effect as the off position, but instead turns on the standby hydraulic pump and pressurizes the standby rudder PCU to achieve standby rudder control and standby yaw damper. Flight spoiler switch. 2 switches, one for each hydraulic system, with 2 positions, on and off. A 28-volt DC motor also powers them. The on position is the normal operating position. Hydraulic system pressure is on to the flight spoilers. And the off position, which removes hydraulic system pressure from the flight spoilers. The flight control low pressure light is a warning switch that gives an amber light indication when there's low hydraulic system A or B pressure to the flight control system. The low pressure light only operates when the flight control switch is in the on or off position. When the switch is in the standby rudder position, the standby rudder shutoff valve controls the low pressure light through the valve position relay. The low pressure light comes on when system pressure is less than 1300 psi. When the low pressure light comes on, there is a master caution and also the flight control annunciator comes up. Yaw damper switch and warning light, which has 1 switch with 2 positions, off and on. In the on position, it engages either the main yaw damper to main rudder if the B flight control switch is in the on position, or the standby yaw damper to the standby rudder PCU if both the A and B flight control switches are in the standby rudder position. Or the off position, which disengages yaw damper. The yaw damper warning light comes on when the system is disengaged. Standby hydraulic low quantity and low pressure lights. These lights come on when the standby system reservoir hydraulic fluid quantity decreases below 50% of its normal quantity. The standby low pressure light comes on when the standby system output pressure from the standby electric pump decreases below limits. Flight control panel warning lights. These are certain warning lights that illuminate when unwanted flight control conditions exist. 1. Field differential pressure light. Comes on when there's a 25% difference between the System A and System B metered output pressures in the elevator field computer for more than 30 seconds. 2. Autoslat fail light. This comes on when the autoslat function becomes unavailable. 3. Speed trim fail light. This comes on when the speed trim function in the flight control computers, FCCs, becomes unavailable. 4. The Mach trim fail light, which comes on when the Mach trim function in the FCCs becomes unavailable. Alternate flaps arm and control switches. This series of control switches are discussed in the secondary flight controls lesson. The 737NG has a complex flight control system, as we've seen during this lesson. There are several essential components and systems. We've also discussed the overall redundancy provided for flight controls. Unlike other early aircraft like the DC-10, the 737NG is very reliable in terms of keeping the aircraft in control during a hydraulic system failure, or control column jams, amongst other problems. The mechanical linkages for ailerons and elevators allow for operation with no hydraulic power through manual reversion. However, we also mentioned that operation becomes difficult because the amount of pilot input necessary to produce flight control surface movement is considerably large. We also discussed a few of the aids that pilots have in order to minimize pilot force input during normal conditions, such as the flight spoilers, yaw damper, and the horizontal stabilizer trim. We encourage you to investigate about the 737 rudder problems and send us your views in the comments section of this video. This lesson covered the following topics: an overview of the aircraft's 3 principal axes and the control surfaces that act on each one of them, basic physics of control surfaces, in other words, moments of force. Primary flight controls on the 737 NGX for pitch, roll, and yaw. Horizontal stabilizer trim, flight spoilers, yaw damper, the Mach trim system, speed trim system, 737 historic rudder problems and RCEP, and the 737 NGX flight control system components. In the next lesson, we'll learn about the secondary flight controls. Until then, throttle on.